Hey guys, Miss James here. How are you? All right, hope you're doing great. I'm doing great. I'm ready to get to this math. All right, so hopefully before you started watching this video, you're up, you got started, and you did these practice problems yourself, and you watched the mini lesson with Miss Fu on how to solve systems of the equation by substitution. All right, so just quick note, pay attention to what's happening in this video, but don't feel forced to I'm gonna explain things at a super slow pace. You are free, like extremely free. This is your video. Fast forward, rewind, pause. It's up to you. Go at your pace. But I'm gonna try to keep things slow just in case there's any problem or question that confuses you. Hopefully, if I go slow enough, you'll feel like you can catch up. All right. So hopefully, as I said before, you watched that mini lesson with Miss Fu. If you didn't, stop, pause this video, and go watch that mini lesson with Miss Fu. Seriously, that's going to be like an in detail way of how to do these type of problems. I'm going to do a recap for you though here, and also I'm going to be using the same steps that Miss Fu used. Same language. I just added a few little tweaks there in brown just to make it even more simplified and broken down. All right. So here's the recap. When you are solving systems of equations by substitution, there are 5 steps that you need to do. The first step says solve the equation for one variable. So all we mean by that is make sure that you have one variable, at least one variable isolated before you even start working. Second step is to substitute. This is solving my substitution. What we mean by substitute is think of replacement, right? You're replacing the variable in one equation for an equivalent expression. You'll see more of that in a second. I'm gonna break it down. Don't worry, I got y'all. All right. Step 3, you're solving the equation. So now that you substituted in a new expression for that variable, you have an equation created. You're going to solve that equation. You're going to use DCMI. Don't call me impossible. Hopefully you remember that. That's a quick throwback from September, October. Don't call me impossible. Distribute, combine like terms, move the variable to one side, inverse operation. That's it. You do that, even if you struggle to solve an equation, you will not fail every single time. Dude, don't call me impossible. All right. Step 4, plug the variable back in to find your next variable. So after you solve for a variable, right? Every time we solve a systems of equation, we're solving for 2 variables. We're solving for x and we're solving for y, right? So let's say you solve for x first. Right after you get x, you're plugging that x right back in to any of the equations so that you can figure out what y is. And after you get an x and a y, you get to step 5. You check your work. It's important to check your work because you want to see if your answer makes sense. You want to make sure that your answer is a solution. All right. So that's just a quick summary of what Miss Fu did with you guys in the mini lesson. Let's get to it. Again, better watch that video of Miss Fu before you get started. Don't peek, don't cheat. All right. So for the practice questions, you guys were instructed to do a set of questions. So you were given questions A, B, and C. You were set to do one question from A, one from B, one from C, and then one more that you chose. So I broke it down into the 3 selections. Go at your own pace, skip around, watch all of them, watch some of them, watch just the ones you did. It's up to you. I just want you guys to feel comfortable with this video. All right. So for question set A, what made these questions unique is that both equations that you're going to see, both equations in the system already have a variable isolated. So that means some of the work is done for you. It's a piece of cake. All right, let's do this. So in order to make this super organized, I think that's the key to solving systems. There's going to be steps, right? So let's make this easy for ourselves. Let's follow the steps. I'm gonna move myself. Sorry about that, guys. Let's follow these steps. I have them on the right-hand corner. And let's organize our papers. So essentially, when you're solving a system of equations, like I said, you're solving for one variable, then you're solving for a second variable, and then you want to check your solution. That's pretty much what these 5 steps are, just broken down into 3 sections on my paper so that I can stay organized. Stay organized, you'll get your right answer, I promise. All right. So first thing first, when solving systems of equations, we know this is a system of equation because we have 2 equations with the same exact variables, right? By substitution, the first thing that we need to do is solve the equation for one variable. So that's step 1. As I told you before, all that means is to make sure that one variable is already isolated. By isolated, we mean just make sure that one variable is next to an equal sign all by itself. So do we see that here? Yeah, we do, right? All right, so y is already by itself. Here it is, here. And y is already by itself here. Awesome. So one variable is already by itself. We can go ahead and check that off. The second thing that we need to do is substitute. And as I told you guys before, just a few minutes ago, by substituting, all we're doing is replacing the variable in one equation with an equivalent expression. So as I'm trying to say, we have y equals negative 4x plus 2, and we also have y equals 6x minus 8. When we substitute, we're just replacing, we know the value of y. In the first one, they told us the value of y is 4x plus 2. So when we substitute, can I just replace this for y down here? Of course I can. All right, if you watched the video of Miss Fu, you knew that. All right. So what I'm gonna do for you guys, I'm gonna color code. Things that already came with the problem, I'm going to write in black. Things that I'm substituting in, I'm gonna write it in a different color. In this case, I'm writing it in red. So we have negative 4x plus 2, right? This is what I'm substituting in place for y. And now let me change my ink color. Is equal to 6x minus 8. All right, so I just substituted in. So step 1, we did. Step 2, just did that. Step 3 now says solve the equation by using DCMI, right? So again, don't call me impossible. First thing to do is distribute. There's nothing to distribute here. If we were distributing, we would have saw parentheses, not here. Okay. Second thing to do is plug, sorry, I lied. The second thing to do is to combine like terms on either side of the equation, equal sign, right? There's no like terms over here. There are no like terms over here. So my next step would be move the variable to one side. So I'm trying to solve for x, but I have an x on this side, and I have an x on this side. So I'm gonna move it to one side. There I go. I'm gonna use a different color just so that you can see what I'm doing. I'll use green. All right. So I wanna move this variable from this side to this side. Doesn't really matter which way you do it, but I'm gonna just move it from the left to the right. So when we move things, it has to be by inverse operations. So because this is a minus 4x, the inverse will be adding 4x. And remember, what you do to one side, you must do to the other. So these are inverse operations, so they give me 0. And I am left with 2 is equal to 6x plus 4x is 10x minus 8. Now, I want to solve for x, right? So I distributed, combine like terms, move the variable. Last thing is to do inverse operations to isolate my variable. So I want to get x by itself. What's on the same side as x that we don't want there? That's right, negative 8, right? So in order to get rid of negative 8, we gotta add 8 to both sides. So I'm gonna add 8 here, and I'm gonna add 8 here. 2 plus 8 gives me 10. So I'm left with 10 is equal to 10x. Again, I'm trying to get x by itself. So I'm going to divide by 10 on both sides because this is 10 times x. So the inverse operation is dividing by 10. And I'm left with x equals 1. Amazing. So I just solved my equation by using DCMI. After I do that, now I need to plug in my x, right? I just figured out what x is equal to, so I can figure out what my y is. So I'm going to pick any of these two equations that I like. I'm going to go for the second one. Why not? It's easier, in my opinion. You could, if you use the first one, that's okay too. But I'm going to go for the second one. All right. So the second one, actually, sorry, I lied. Like I said, the question, the original question, I like to leave it in black for you guys. And when I'm substituting in, I like to color code. I'm trying to solve for y. I don't know what y is, so it's going to stay as y. The 6 already came with the problem. And now I know what x is. So because I know what x is, I'm going to, x is 1. We figured that out here. Minus 8. So y is equal to 6 times 1, which is 6, minus 8. So y is equal to negative 2. So now I just figured out what my x is, and I just figured out what my y is. My last step is to check my solution. So again, I can take either one of these equations and substitute in to figure out what my x, to see if my x and my y value makes sense. So let me just use, I'm going to use the first one. You could use whichever one you please. I'm using the first one just because. Okay, so y equals negative 4x plus 2. So I figured out that my y was negative 2. Is equal to negative 4. My x we just figured out was 1, right? So negative 2, I bring that down. Negative 4 times 1 is negative 4 plus 2. Negative 2 is equal to, what's negative 4 plus 2? Negative 2. So this works out. That means that this is a solution. And as Ms. Fu did, we could always write our solutions because they're ordered pair as x comma y. My x was 1 and my y was negative 2. So that means this is a solution to the following systems of equations. Go ahead and give yourself a pat on the back if you got that right. Shout out to you. You are amazing. All right, cool. Let's move on to the second question for A. All right, second question, as I said for A, very similar. It says solve the equation for one variable. As I told you, all that means is make sure that one of these variables is isolated. So make sure one of your variables is alone next to that equal sign. Do we see that here? Yeah, we do. Y is all by itself just next to that equal sign. Perfect. So that means step 1 is done. Step 1 is done. Love that. All right. Step 2 says substitute. So what we're going to do when we substitute, we're replacing the variable in the equation, one of these variables, for an equivalent expression, right? So here, they told us y is equal to negative 3x plus 4. And they also told us y is equal to 4x minus 10. So because y is equal to negative 3x plus 4, that means everywhere I see y in my equation, I can replace it for negative 3x plus 4. I'm going to do that now. Negative 3x plus 4 is equal to, right? Because negative 3x plus 4 is the same thing as y, is equal to 4x minus 10. So 4x minus 10. Okay, so now I just substituted. The next thing, solve this equation that you made by using GCMI. Cool, so there's nothing to distribute. there are no like terms to combine on either side of the equal sign. So I need to move the variable. So let's move the variable. I'm going to use, I get so excited about this. Okay, so I'm gonna move the 3x, the negative 3x. If you wanted to move the 4x, it's not a problem. This is just my choice. I'm gonna add 3x on both sides because the only way you can move variables is by using inverse operations. Doing inverse operations causes that to go away, it gives me 0. And I'm left with 4 is equal to 4x plus 3x is 7x minus 10. Okay. So now, again, I'm not done until x is by itself, but I have something on the same side as x, so I need to get rid of this. So this is negative 10, inverse operations, I add 10. And I'm left with 14 is equal to 7x. What operation is happening between 7 and x? You got it, it's multiplication. So we need to do the opposite operation or the inverse operation and divide. So we figure out that x is equal to 2. Awesome. So x is 2. Now I'm going to solve for the second variable. Sorry. To solve for our second variable, right? What we are going to do is plug in our value of x into one of these equations, any one of these that we want. So I'll just use the first one, just because in the last one I used the second one. I just want to switch it up for y'all. All right, so the first one, this is the equation, y equals 4x minus 10. So I'm going to substitute in, sorry, JK LOL. I don't know what y is, so I leave that as y. 4 came with the problem, so I got to leave that there. I know what x is. We just found that together, right? X is, yep, it's 2. All right. Excuse the corniness. I got to pretend like I got a class in front of me. I got to pretend. All right. So y is equal to, what's 4 times 2? Yep, it's 8. Y is equal to 8 minus 10. So y is equal to negative 2. Last but not least, we're going to check our solution to see if it makes sense. So we choose any of these that we want. I'll use the first one. But like I said, you can use whatever you want. So it says y equals negative 3x plus 4. So I just figured out, or we figured out together, that y is equal to negative 2. So negative 2 is equal to negative 3. We figured out that in place of x, we can substitute in 2, right? Because we solved for x and it was 2. And then plus 4. So again, we're making sure that our answer makes sense. If we did all this work, we want to make sure that when we submit our answer, that it's right. So negative 3 times 2 is negative 6. And then bring down the 4. And negative 2 is equal to negative 6 plus 4. Well, what's negative 6 plus 4? Is negative 2. If negative 2 is equal to negative 2, if that answer makes sense, that means that this solution makes sense. So we can write this as an ordered pair, x comma y. So x is equal to 2, and y is equal to negative 2. That's it. That's our solution. Told y'all that would be a piece of cake. All right, let's move on. All right, so question set B. In question set B, what makes this slightly different, but still not hard, not challenging at all, well, I'm saying that, but I'm a teacher. Sorry, guys. What makes it hard, not as challenging, is that one equation here has a variable already isolated. So similar to that one, to question set A, you had two equations that had a variable isolated. Here you have one that's isolated. So again, a little bit less work, nothing crazy. All right. So steps are the same. We're solving the equation for one variable, right? So we need to ask ourselves, is one variable isolated? Excuse me, is one variable isolated? Is one variable all by itself next to an equal sign? Is it? Do you see it? All right, there it is. X is all by itself next to the equal sign. So that means step one is done. I told you this one is not going to be bad. It's actually going to be exactly like the first. So if you were able to do set A, you are not going to struggle too much with step B. The only thing that you want to keep in mind is for step two, to substitute. When we substitute, and I really should have said this early, shame on me. When we substitute, it's super important. Use parentheses, please. Super important. All right, so they gave us two equations. It's a systems of equation, as we know, because we have two equations, each of them having the same variables. One has an X, one has a Y. So this is a system, right? So what we're trying to do is to figure out what the value of X and Y is. They already tell us X is equal to 3Y plus 1. And so we're able to substitute that. So that if X is equal to 3Y plus 1, that means everywhere we see an X in this question, we are going to replace it for 3Y plus 1. But what you need to do is when you replace it, you need to use parentheses. If you don't use parentheses, I'm telling you, you are going to make an error. Well, actually, for sure, you're going to make an error. There's just no way. If you find a way, show me. All right. So I'm going to, again, write in black the things that came with the problem. And I'm going to write in purple what we're substituting in. So this original problem said 2 times X plus 4Y equals 12. So we figured out, again, they told us that X is equal to 3Y plus 1. So everywhere we see X, we're just replacing it with 3Y plus 1. Okay, so 2 times 3Y plus 1. I'm switching back to black because I'm copying again from the problem. Plus 4Y equals 12. Okay. I'm trying to be neat, guys. Be neat, be organized. That's the only way you're gonna get these answers right. It's gonna get confusing if you're not neat. All right, so we just substituted. So the next thing is to solve this equation by using DCMI. The first thing that D, it stands for distribute, right? So we're gonna distribute. Every time we see parentheses, that gives us a clue to multiply what's outside the parentheses by both terms in the parentheses. So if you made, most people, this is where they make the error. They forget to distribute both terms, right? So what's 2 times 3y? 6y. And what's 2 times positive 1? 2. And then I'm gonna just write again in black the information that came with the problem. So you see I'm not changing anything. Okay, so we distribute. Now we have to see, are there any like terms on both sides of the equal sign? That's the C, combine like terms. Is there? You see it? All right, I see it too. So the 6y and the 4y, they go together, right? So 6y and 4y, they're like terms because they have the same variable, same exponent, right? 6y plus 4y is 10y. So 10y. The 2 is not like terms with anything. I can't use that. So 10y plus 2 is equal to 12, right? Again, we distribute, we combine like terms, times to see if the variable is on one side. It is, nothing to move. So I just need to do inverse operations to isolate that variable. So The variable that I want to get is y. So what's on the same side as y that we don't want there? That's right, positive 2. So how do we get rid of it? Inverse operations, negative 2. So 10y, these things go away because they're opposites, they're inverse, they disappear, they give me 0, right? And what's 12 minus 2? 10. So I'm left with 10y equals 10. The operation happening between 10 and y is multiplication, so inverse is division. I divide by 10, and I'm left with y equals 1. So now I figured out that y equals 1. I solved the equation for my first variable. Now I need to solve for my second variable. So as I said before, to do this, you pick any equation, whichever one honestly feels easiest for you to work with. I'm gonna go with the first one because there's a lot less going on. So you plug back in your solution back into the first equation. So again, let me use black. Did I do that already? Nope. Okay, so the equation was x equals 3y plus 1. So I'm trying to figure out what x is. I already found y, so I don't know what x is, so I leave it as x. The 3 already came with the problem, so I bring that down. We figured out that y is 1, so why don't we go ahead and put that there. And the plus 1 came with the problem, right? Okay, so x is equal to, what's 3 times 1? That's 3. And what, bring down the plus 1. So x is equal to 4. And that's that. Now I need to check my solution to make sure that it makes sense. So you take any one of these equations. Again, I'm going to just use the first one, x equals 3y plus 1. And you substitute in your values of x and y. So I have x is equal to 4. So 4 should be equal to 3 times y we figured out was 1 plus 1. So 4 is equal to 3 plus 1. 3 times 1 is 3. So 4 is equal to, what's 3 plus 1? That's 4. So that works out. So we checked our solution. That made sense. So we can write our solution as an ordered pair, x comma y. Our x is positive 4, and our y is 1. Told you guys that wouldn't be bad. All right. Whoopsie daisy. Okay. Sorry about that. That was super weird. Mistake number, 83 for me? Oh, wow. All right. Actually, just one more thing. Now I completely disappeared. There I am. Okay. So second question set in B, you again have to check, is one of your variables isolated? Is it all by itself? Excuse me. So it is, right? This is y equals. That means it's all by itself. There's nothing next to y on that left-hand side of the equal sign. It's all by itself. Step 1 and done. Yes. All right. So that means that we can just move on to step 2. Step 2 says, let's substitute. So if they told us what y is, that means everywhere in the problem that we see y, they said y is equal to negative 3x plus 5. That means everywhere in the problem that we see y, we can replace it with negative 3x plus 5. So where do you see y? Is it there? Is it there? All right, it's right there. I'm just being silly. All right, so again, super important, when you substitute this in, please use parentheses. So we're saying that in place of y, we're going to substitute in this negative 3x plus 5. All right, so what I'm going to do is write the problem what they gave us in black. So what they gave us, I'm going to substitute in this into this equation, right? Because this is, we know now what the value of y is. So 5x minus 4, like we said, the value of y everywhere we saw y, we were going to replace it using parentheses with negative 3x plus 5. And all of that is equal to negative 3. Awesome. Okay. So same like before, we made sure that one variable was by itself. We substituted. Now it's time to solve that equation using ZCMI. So the first step, again, distribute, right? So every time we see parentheses, that's a clue for us to distribute the number outside of the parentheses with the terms in the parentheses. And distribute is just multiplying. Parentheses, multiplication. All right, so again, let me put things that came with the problem in black. 5x minus 4. The distribution, I'm gonna write in red, right? So what's negative 4 times negative 3x? Well, negative, oops, that was a mistake. Whew, that was a mistake, don't tell nobody. Sorry, I just needed to distribute. Sorry, so I'm distributing negative 4 times negative 3x. So negative 4 times negative 3x, a negative times a negative is a positive 12. 4 times 3 is 12, and then the x. And then negative 4 times positive 5 is negative 20. If you don't know, this is again the area where people mess up. I'm not even gonna lie to you guys. I messed up doing these questions because I made a slight miscalculation integer rules, right? Like, so just be careful. If you don't know, use a calculator. It's easy. Don't be a hero. All right. So 5x. Oops. Sorry, guys. I'm getting too excited that now I'm making like all these little mistakes. So I distributed, I combined. I need to look to see, can I combine like terms? So is there anything on the left-hand side of this equation that has like terms? Yes. 5x and 12x, those are like terms. They both have the x. So 5 plus 12 is 17. And so that's 17x. So 17x minus 20 is equal to negative 3. And now I'm going to try to solve for x, what's on the same side as x that I don't want there, negative 20. So I do inverse operations. I add 20 to both sides. And I'm going to put 17x is equal to negative 3 plus 20. Signs are different. I subtract, keep the sign of the bigger number. So it's equal to 17. Operation happening between 17 and x is multiplication. So inverse is division. I divide by 17, and I'm left with x equals 1. All right. Now that I figured out what x was equal to, I solved for my first variable. I got to figure out what my second variable is. So I'm going to substitute back in the value of x to either one of these equations. I'm going to use the first one. It's just more clean cut because y is already by itself. I feel like it's just one less step for me to worry about. So I'm going to use the first one. I'm going to go select my black ink. The first question said, y equals negative 3x plus 5. So I don't know what y is. That's what I'm trying to solve for. Equals to negative 3. We just figured out that x was equal to 1. Plus 5. So y is equal to, what's negative 3 times 1? That's negative 3 plus 5. And y is equal to negative 3 plus 5. Signs are different. You subtract, keep the sign of the bigger number. So y is equal to 2. Done. Last but not least, I'm going to check my solution, make sure that my answer makes sense. So I pick any one of these. You know what? For the sake of it, I'll use the second one. Any one of these to see, does this answer make sense? So 5x minus 4y is equal to negative 3. I figured out that we figured out together that our x is equal to 1, right? We figured out together that our y is equal to 2. So now what's 5 times 1? That's 5. Negative 4 times 2 is negative 8. And we're hoping that's equal to 3. 5 minus 8 is negative 3. So negative 3 equals negative 3. That works out. That means that that is a solution. So now, because it's a solution, we can list this as an ordered pair, x comma y. So x is 1, y is 2. This is our solution. All right. So question set C, this is when things get real. What I mean by that is neither of these equations have a variable that's already isolated. So what that means is we got to do a little bit extra work. It's all right though. We got this. We got this. All right. So question says C says, same steps. I'm sorry. I'm just going to go through them every single question set in this video. So solving the equation for one variable. So what I told you before, or what Ms. Fu and I have been emphasizing before, is we're just trying to make sure that one variable is isolated before we start. That means that that variable is alone on the equal sign. Do we see anything like that here? No, right? Both of these variables are with other things on each of the equal signs. So what we have to do for step 1, before we can do anything, is isolate a variable. So that's like our first step. So what we're gonna do is look at both of these equations and which one has a little less going on, right? So if you look at the variables, there's 2 variables in the problem. There's an x, there's a y. Next to this x, I have something next to it. Next to this y, I have something next to it. Next to this x, I have something next to it. This y is by itself. So that tells me that this is the one that I should try to use to solve for y. So what I'm going to do is rewrite the equation just exactly how it appeared, using black ink to make this easy for you guys. So it said 5x plus y equals negative 13. I am going to solve for the variable y. I want to know what y is equal to. That way, it'll be just like the problems that we've been working on before. So how do I solve for y? Well, what's on the same side as y that we don't want there? All right, you see what it is. I'm always hovering over the things, so I didn't even really give you guys a chance. All right, so the 5x is on the same side as y. We don't want that 5x there. So how do we get rid of it? We do inverse operations. That's the only way you can get rid of things in math in solving equations. So if this is positive 5x, in order to get rid of it, we are going to subtract 5x. And what you do on one side, you have to do to the other. Alrighty. So now my new equation, these go away. They're inverse operations, right? I'm left with y equals, as Ms. Fu said in her previous video, let's try to keep this in y equals mx plus b form. It's easier to work with. So I'm left with y equals negative 5x minus 13. So this is my new equation, right? So I know that y is equal to negative 5x minus 13. That means that anywhere in my equation that I see y, I can replace it for negative 5x minus 13. So now I did this, I can substitute in like I was doing before. So really, question set C, same as before, just one extra step. So again, I said y is equal to this expression. This is what y is equal to. So anywhere in my expression, I'm gonna just choose the second one because like I said, had a lot less going on. But I see y, I'm replacing it for negative 5x minus 13. Okay? So now what this should look like, I'm gonna again write this in blocking, what came with the problem. 5x plus y equals negative 13. So I'm gonna replace this for 5x. We just figured out that y is negative 5x. So actually, let me use writing 5x plus, again, when we substitute, we use parentheses, make it easy for ourselves so we don't make any mistakes. 5x plus negative 5x minus 13. Sorry, is equal to negative 13. Actually, oops, sorry. Okay, question set C. So what makes question set C unique, as we said before, is we're trying to make sure that one variable is by itself, right? So if you look here, and we have two variables, we have an x and a y. In this first equation set, we have a 6 next to this x. So something's next to that. Next to this y, there's something next to that. Next to this, there's something next to this, right? And next to this y, there's nothing next to it. So this is the one that I'm gonna try to isolate, right? Before we get started, as we said before, step one is to try to isolate your variable. So I'm gonna have it y . All right, so let's try question set C. The first one, we have 6x plus 6y equals negative 6, and we have 5x plus y equals negative 13. So as before, our steps are here. The first step is to solve the equation for one variable. And as I've been saying throughout this video, all I mean by that, or all we mean by that, is make sure that one variable, at least one variable, is isolated before you start. So in this set of equations, neither variable, neither x or y, is isolated. We said isolated means it's all by itself on one side of the equal sign. That is not the case here. There is something on both sides of the equal sign happening, right? So what we need to do is figure out which variable to isolate. So I'm gonna isolate the variable that is the closest to being by itself, right? this x and this, there's an x and a y in each of these equations. This x is next to a 6, this y is next to a 6, this x is next to a 5, and this y is by itself, right? So that makes it just a little easier to isolate it. So we want to get, let me just undo that. We want to get this equation to be in a different format where y is all by itself. So I'm going to rewrite the equation. 5x plus y is equal to negative 13. And what we're trying to do is get y all by itself on one side of the equal sign. So in order to do that, we need to use inverse operations to get rid of anything else that's on the same side as the equal sign. So what's on the same side as the equal sign of y that we don't want there? Oops, undo. All right, while I'm making that mistake, you tell me what's on the same side as the equal sign that we don't want there. All right, so we don't want this positive 5. And so in order to get rid of that, we use inverse operations. We subtract 5x on both sides. I'm going to rewrite this now. These go away. I'm left with y is equal to, I'm going to rewrite this in y equals mx plus c form. This is what Ms. Fu did in the mini lesson video. So y is equal to negative 5x minus 13. So now I know that anywhere I see y in this equation, I can replace it for negative 5x minus 13. So this is what y is equal to. That means I can go to this equation and replace y for negative 5x minus 13. Remember, when we substitute, we want to use parentheses to make our lives easier and to make sure we get the problem right, right? Parentheses is to group this whole entire expression. So what I'm going to do, again, rewrite the equation using black ink, and where I substitute in, I'm going to use red ink. So 6x plus 6, that came with the equation. Now, instead of y, we said we're going to replace it with negative 5x minus 13. And all of that is equal to negative 6. Okay, so now we solved the equation. I forgot to check this off, so sorry. We solved the equation for one variable. We substitute in what the value of y was. And now we're going to solve the equation by using DCMI. So as always with DCMI, when we see parentheses, we got to think time to distribute. So what I'm going to do first is just, again, 6x that came with the question. And now I'm going to do my distributing. What's net positive 6 times negative 5? That's negative 30x. And then what's positive 6 times negative 13? Take a second, use your calculators. All right, so you did that. Positive 6 times negative 13 is negative 78. And that is equal to negative 6. Now I look to see, do I have any like terms that I can combine? I do. Of course I do. 6x and negative 30x are like terms. So 6x minus 30x gives me minus 24x minus 78 is equal to negative 6. My next step is to move the variable to one side. It's already on one side, so I just lastly end with inverse operations. So this is negative 78. I'm going to add 78 to both sides. I'm left with negative 24x is equal to 6 plus 78. I'm just looking because I did this question in advance. Negative 6 plus 78 is positive 72. Again, I want to divide by negative 24 on both sides to get x alone. And I'm left with x is equal to negative 3. Now I figured out what my x is. Lastly, I need to solve for my second variable. Give me a second. Okay, so as always, when we solve for our second variable, we're just choosing any of these equations to substitute back into. Now that we know the variable, the value of x, we're gonna substitute back in. So I'll use the second one, right? The second one, use the pen, flat pen. It says 5x plus y equals negative 13. So 5, we just figured out together that x is equal to negative 3 plus y oops, oh my goodness, that was clearly a mistake. X is equal to negative 3, sorry. I wrote negative 13. Plus y equals negative 13. Okay, so 5 times negative 3 is negative 15. So negative 15 plus y equals negative 13. I want to get y by itself. So I add 15 to both sides. And I'm going to put y equals negative 13 plus 15 is 2. Lastly, I need to check my solution to make sure that it makes sense. So I'm going to take any one of these equations. I'll use the first one again. 6x plus 6y equals negative 6. And my goal is when I substitute in, I get an answer that makes sense. So 6, we determine that x is negative 3. Plus 6. We determine that y is positive 2. And we're hoping that that answer is equal to negative 6. So let's see. So negative 6 times positive 6 times negative 3 is negative 18. And 6 times 2 is 12. And that's equal to negative 6. Negative 18 plus 12 is negative 6. So negative 6 is equal to negative 6. That works out. Check our solution. So that means that this is an ordered pair. So our ordered pair, remember we write them x comma y. This is our solution, negative 3 comma 2. This is our solution. All right, last question, almost there. We almost did it, we made it. All right, so same set of steps. You're solving this equation for one variable. We're gonna substitute, solve the equation by using GCMI and then plugging back in and checking our solution. So again, none of these variables, neither x nor y, are by themselves. They all have, they each have something else, a coefficient in front of it, and other things happening on the left-hand side, the same side as that variable. So none of them are by themselves. For this question, what I'm gonna try to do is just get x by itself first. So what I'm gonna do, I'm gonna just pick the first equation. The first equation has the following. It has negative 2x plus 6y is equal to 6. You might ask, how do you get this equation? How do I get x by itself, right? And why am I getting x by itself? Well, I'll just tell you beforehand, if you try to do it by solving for y, what's gonna happen is you're gonna end up with fractions, nasty numbers, unless you have a little calculator or you're really familiar with working with fractions. I wouldn't go down that route. So I'm gonna just solve for x. Okay, so we get negative 2x plus 6y is equal to 6, right? That's our original equation. I wanna get x by itself. And so what happens, what I need to do to get x by itself is look what's on the same side as x that I don't want there. So 6y. So I'm going to subtract 6y on both sides. And I am left with, I'm just going to write this in another color, 2x is equal to negative 6y plus 6. Okay? And again, x has to be all by itself. So what's on the same side as x that I don't want there? This negative 2. So I'm going to divide everything by negative 2. And I'm left with x is equal to negative 6 divided by negative 2 is negative 3y. And positive 6 divided by negative 2 is negative 3. So this is now what x is equal to. X is equal to negative 3y minus 3. That means that I can take my second equation and everywhere I see x, I can substitute in this negative 3y minus 3. I will substitute that into there. That's where I see my x. And again, when I substitute, I need to use parentheses because this is a big thing that x is equal to. I need to make sure that that stays together and it's being grouped. Okay, so I'm gonna write my original equation in black ink for you all. And then, again, what came with the problem, I'm gonna keep in black ink. When I'm substituting, I'm gonna put it in purple ink. We said that we know that x is negative 3y minus 3. And we know that plus 8y is going to give us negative 5. So we just substituted. So we're going to solve the equation by using GCMI. My lips are dry. I'm really thirsty. So let's wrap this up. We have negative 7 times negative 3y. So GCMI says to distribute, right? So negative 7 times negative 3 is negative 21y. And then negative 7 times negative 3 is negative 21. Sorry, positive 21. A negative times a negative is a positive. Plus 8y equals negative 5. Now, we look for like terms to combine. So the like terms we see here are negative 21y and 8y. So it's negative 21 plus 8. We subtract, we keep the sign of the larger number, and we're left with negative 13. And we're left with negative 13y. So negative 13y, where'd I go? Here I am. negative 13y plus 21 equals negative 5. And now we want to get y by itself. We subtract 21 on both sides. And we're left with negative 13y equals negative 26. Divide by negative 13 on both sides. And you're left with y is equal to positive 2. Sorry guys, I just paused the video just to be a mom. All right, so now we figured out that y is equal to positive 2. We need to, so we did that. Now we need to figure out what our other variable is. So we're gonna plug back in the variable, we're gonna plug back in the value of y into this equation. So any equation that we want, I'll use the first one. So it's that negative 2x plus 6y equals 6. So negative 2, we don't know what x is yet, plus 6. We just figured out that y is positive 2. And that's equal to 6. So negative 2x plus 12 equals 6. I'm going to use a different color. I'm going to use blue just so that we don't get confused with what's happening on the other side. Negative 2x plus 12 equals 6. We want to get rid of the 12 because we're trying to solve for x. So we're left with negative 2x equals 6 minus 12. It's negative 6. We divide by 2 on both sides. Negative 2 on both sides, I'm sorry. And we're left with x equals 3. Lastly, we're going to check our solution, make sure that this answer makes sense. If you made it here, you're probably just as tired as I am. All right, so negative 2x. I'm using blue ink, my fault. But I'll write the original equation in black ink. Let me stay true to that. So negative 2x plus 6y equals 6. So we're checking our solution by substituting in the values of x and y. So negative 2, that came with the problem. We figured out that x is positive 3. We figured out that y, plus 3. Okay, what is happening with my life? That is, I'm just gonna make this in blue. Sorry about that. Okay. Plus 6 times 2 equals 6. And we're hoping what we get on the left side matches what we have on the right side. So what's negative 2 times positive 3? That's negative 6 plus 12. This is 12 is equal to 6. That's 6 equals 6. That makes sense. So we are good. So our ordered pair is x comma y, so that's 3 comma 2. If you got these answers, just give yourself a pat on the back. If you made it this far, we can wrap it up. We are done. Bye. Make sure you wash your hands. You don't want to have any germs on them. Wink, wink, cough, cough. I'm just being silly. All right. Bye, guys. Take care.